Well, hello. So today we're going to be looking at lengths of segments in a circle. By segments, I'm talking about line segments. So lengths of line segments of a circle. And so um, when looking at this, we have two things we'll look at. The first one will be when we are inside of a circle. So we're looking at line segments that are within a circle. And the second one will be when we're looking at line segments that are outside of a circle. Okay. So let's begin with inside the circle. And those of you that have ever played Smash Brothers, this symbol may look similar or familiar to you. Um, so yeah, but anyway, so what this is an intersection of two chords. Remember, a chord goes from one point on a line on a circle to another. Chord going from one point on a circle to another. So that's the line segment that's formed there is a chord. So this is an intersection of chords. Well, if we know three of these lengths here, we can find the fourth one quite easily, actually. It turns out that whenever the chords are split this way, or with this intersection of two chords, it turns out that if you multiply the two pieces of the chord, they equal the product of the other two pieces of the chord. So in this case, we get A times B equals C times D every single time. Okay, so what does that mean exactly? Well, if I, for instance, had, let's say, I knew that this was 10, and I knew that this was 2, then that means that if this side was 5, I could find the missing side quite easily. Okay, so how would I do that? Well, according to what we just talked about, the intersection of two chords, the products of the segments that are formed have to be equal. So 2 times 10 has to equal 5 times x. In this instance, 2 times 10 has to equal 5 times x. And so we end up getting 20 has to equal 5x. And then therefore, we see that x would have to equal 4, right? Okay. So sometimes what happens is, and this is a rarity, but sometimes this does happen, you don't know what the other side is. You don't know what the other side is. So let's say you didn't know either one of these two sides. How would you find out what you have? You couldn't. It's an infinite number of possibilities. Although you do have some limitations, right? Um, you know that these two things have to multiply to give you 20 in this case. X times y has to equal 20. And maybe you'll know that this side definitely is smaller than 10. So that gives you some kind of room of to figure out. But even still, we know that these two things have to multiply to 20. So if you were able to actually find out one of them, you could easily find the other. But otherwise, this gives you an infinite number of answers. And for some people, are like, no, it doesn't, because these have to be whole numbers. No, they don't have to be whole numbers. They can be decimals. Um, but regardless of that fact, um, we do know that if the product of these has to be equal. Okay, so if you do get a result like this, like if you were in the real world and you knew the two segment lengths you had here, but you couldn't figure out the others for some reason, you would not be able to find either one of them. You could give a range, but you would not be able to find out what they were each. Okay? All right, so that was just an important thing to know because I have seen people in the past, well, they'll say that, well, this has to be less than 10, so I'll say like it could be 9. Well, what does that mean the other side has to be? And where's the balance between that? So again, you can get some kind of range, but it doesn't mean you get it exact because this could be the diameter, so it could be the longest side, and then you may not know that it's the longest side. All right, but regardless of that, again, this is simple, quite simple. You multiply these two sides here, set it equal to the product of these two, and then solve for the unknown every single time. Okay, so that's the first way that we can find links within a circle. So let's do one more example of this, just because it's fun. Let's say I split this and I do actually know, I know that so for some reason that this chord split this one in half. Okay, so this is x and that's x. So you may say, well, you just told me if I have two unknowns, I can't solve it. We don't have two unknowns, we only have one. because these values are the same. So what we end up having is that 2 times 10 has to equal x times x. And we know that 2 times 10 is 20. We also know that x times x is x squared. Can we solve for x here? Yes, we can. We can take the square root of both sides. And so x is equal to the square root of 20. You may say, what about the negative version of that? Does it make sense to have a negative length? No. So in this case, once again, we will only be dealing with the positive version of it. So x would have to equal the square root of 20, okay? Which we could approximate further to be 2 times the square root of 5. If we wanted to, we could put it in the calculator and get a even better approximation. Well, this is an approximation, this is exact, but we could get an approximation by substituting that into the calculator. Okay? All right, so that is how we can find lengths that are inside of a circle. Let's take a look and see what else we can do, shall we? So what happens when our lengths are outside the circle? Well, how is that even possible? Well, first let's look at this case. So I have my 2 tangent lines here that are outside of my circle. And they intersect at this point out here outside the circle, okay? Well, if I know that this side is 7, I want to find the length of the other side. Well, how am I going to do this? Well, it turns out this side also has to be 7. Why? Well, if my center of my circle was here, this would be a radius. This would also be a radius. Well, what do we know about the radius in a tangent line? They form a 90-degree angle. Okay, and some of you may say, "Oh, I see how both of these have to be the same measurement now." Okay, but if you still don't, what do we know about the radius? They're the same. So, for instance, if this was 24, this would have to be 24. Okay. If you still can't see it, well, if I draw from this point to the center, I have formed the right triangle. And I automatically know that this line is the same as itself, right? It's always going to be congruent to itself. It's the same measurement of itself. It can't change its measurement if it's still the same thing. And I know that these two radii have the same measurement. They're congruent. Well, this formed the triangle, and the angles are the same. That means that this has to be the same length. So if you have 2 tangent lines that intersect the circle, and they intersect each other at a common point, the measurement from that point to the point of tangency has to be the same, always. Okay, and that's really powerful because that also means that this angle has to be equal to this angle. If that's ever drawn to the center there, these 2 angles also have to be congruent because you have tangents formed. Because you have tangent lines that intersect the circle that intersect outside of the circle. Okay. All right, cool. And because of this information now, you actually could find out all of the angles of this and actually find out the measurements of these arcs as well, just based off of the simple fact you have 2 tangents drawn, and if you're given one of the radii, you can find out everything else you wanted to about this circle, because now you could use trigonometry to find the angles. These angles will be central angles, so you can find the measurements of these arcs. The total arcs need to be 360 degrees, so you can find the other side of it. You can keep going and going and going. There's so much just from the fact that we have 2 tangent lines that intersect outside the circle at a common point, and because of what it means for the line to be tangent. All right. This is usually the most fun for people because as soon as they see those 2 tangent lines, they're like, "Oh, those are equal. Those are equal. I know those are equal. Let me do everything else." Okay. All right. So that's if you have 2 tangent lines. But sometimes you don't just have 2 tangent lines. Sometimes this is what you have. you have a tangent line and a secant line. So secant line going through the circle, tangent line outside the circle is intersecting only once, secant intersects twice. Okay. Well, how does this work? Well, it turns out that, let's say we know that this is 3, and we know this is 4. Let's make this. Let's leave it 4. Yeah, let's make that 4. And I want to find out what's the length of this tangent line. How am I going to do that? Well, it turns out that this is very similar to what happens inside, except we have to take into account what happens outside. So to find this, we would take the total length of this secant here. So we would take the total length, which would be 3 plus 4, multiplied by how much is outside, and that will equal the same thing for over here. So the total length, which in this case was x, times how much is outside. Oh, x. Okay, so you take the total length times how much is outside. Set it equal to the total length times how much is outside. And when we do that, we end up with 7 times 4, which is 28, equals to x squared. So we take the square root of both sides. So the square root of 28 is x. So that's the length of this side here. And you could approximate out what that is. All right. That's where things start getting really fun, because we can set this up quite easily and then use algebra to solve for x. Okay. Well, let's look at another example with this, shall we? So let's say this is 9 and this is 3. And I want to find out what x is. Okay. So if we take the length of the entire thing, 9 plus 3 will be 12, times how much of it is outside? 3. It's going to be equal to the entire thing, x, times how much is outside, which is x. So we get 36 equals x squared. Take the square root of both sides. We end up getting that x has to be 6. So this will be 6 in this case. All right. So again, for if you have two lines that intersect outside of a circle, we can find parts of their lengths based off the fact that if you take the entire measurement, so from the circle to the point where they intersect, times how much of it is outside, set equal to the same thing for the other one, we can use that relationship in order to solve for pieces of it. Bless you. All right. Now, this was for secant tangent. What if we have two secants? Okay. So let's say we have two secants. So if I say again, let's just use the same one we had before. Say we have 9 and 3 here. Let's say that's 4. So we have 9 and 3, and then we have 4. Okay, so this is actually the same as what we did before, except now it's not a whole tangent line outside. So if we take the measure of the entire thing, so this would be 9 plus 3. So I'll write it out that way for starters. 9 plus 3 times how much is outside, so 3. We can set that equal to this unknown, so x plus 4 times how much of that is outside, 4. All right, so we get 12 plus 12 times 3, which is 36. And we set that equal to x plus 4 times 4. So x plus 4 times 4. Well, how would I get rid of the 4 here? I would divide both sides by 4. And so in this instance, I would get 9 equals x plus 4. Therefore, x would have to be 5. Okay, so x would be 5. Well, let's see if that makes sense. 12 times 3, 12 times 3, 12 times 3 equals 36. 9 times 4, 9 times 4 also equals 36. So this has to be sound. It makes sense. It equates as it should based off what we said about the intersection of lines outside of a circle. Okay. So if we knew how much is outside of it, we could easily find this chord inside. So how could this actually be used? So let's say you have to drill holes on the circle in this area, and you know the length out here, but you don't know what the length of this line is. You want to make sure it's a certain length. Well, if we were to just take this measurement that we may know already, maybe we've already drilled it and we know what that measurement is, and we see where our lines will intersect outside, we can easily take these two measurements on the sheet. We could find out what that has to be using algebra. So taking this whole thing times how much is outside, setting it equal to the whole thing times how much is outside, we could use algebra to solve what that measurement should be. Okay. All right. We could take this in the other direction and find out how much should be outside. In doing so, however, we will end up with a quadratic equation, which you have not seen how to solve yet. But if you would love to know how to solve that, let me know, and I'll teach you how to. It's actually a lot of fun. It's one of my favorite things to do. All right, so that's how you find the lengths of a circle. So we saw that when you had intersection inside of the circle, you took the product of each section of the segments. So let's see. So you had A times B equals C times D. All right. And when we have our measurements outside the circle, or our intersection outside the circle, if it was two tangent lines, they had to be equal. Think of it even with this concept. The whole thing times how much is outside equals the whole thing times how much is outside. They have to be equal. You can probably clearly see that now. If it was a secant with a tangent or a secant, it's the same thing. Take the whole thing times how much is outside, the whole thing times how much is outside. Set them equal. And that's it. That's how you find lengths of a circle. All right, we've done a lot. We've looked at angles. We've looked at line segments. We've looked at portions of a circle. We've looked at almost everything that you can do with a circle. Almost. We'll look at some more things with circles in the future, but we've covered the basics. And with the basics, we can continue to build upon our foundation to solve all types of problems involving circles and any other shapes. So that's it for the lengths of circle, and I'll see you soon.